Welcome to the last session of this week. So we're really excited. When we say we, I want to introduce my colleague Jitka Hügle, who wasn't on the list, but who was planned to co-lead the session along with me all along. Today, we're going to try something different, something you might not have seen SAP do, but something that we are really excited to share with you, where we kind of look at to do something ourselves, to experience AI and machine learning and to program something cool ourselves. Let me give you a quick glimpse of what the session is about. I'm going to share my screen and show a little presentation. Jitka, can you please indicate, can you see my screen? It's supposed to be a blank screen.
Yes, I can.
Okay, great. So at the end of the session, you're all going to have programmed a little program that looks like this, a blank screen, where when you sketch a heart, the heart will come to life and do something like here it's going to blink. Or you might draw something else and it might come to life and fly. You might be able to tell stories by just sketching some of the parts that you're able to use for a story. For example, when I invited you for this, there's something like when I said pack your bags, kind of come to our workshop, we'll travel together. And this is the kind of app that we're going to build together today. And there's going to be a surprise guest somewhere in the middle, whom you might know or not. It's going to be fun. And the guest is going to be Dr. Mark Guzdial from the University of Michigan, who's going to tell us about his experience with the very gesture recognizer module we're going to do today. So this session is going to be structured in kind of 3 parts. Right now we're at the intro. We're going to give you a quick overview of what the module is all about, and we're going to start coding right away to do some fun things, some easy things, and then they're going to get a little bit more difficult. At around 12:30 Eastern Time, Mark is going to come in and is going to delight you, I hope, with his experiences. At around 1:30, we're going to have a lunch break, late lunch break, because we're going to have Mark before. And then at 2 p.m., we're going to start coding for real for 2 hours. And after 2 hours, everybody of you is going to have this program that is going to be able to recognize things that you sketch, anything you sketch. And we're going to take a little creative break where you're going to tell a story with that. And then at 4:30, we're going to meet for one final round of closing of show and tell. Okay, let me unshare my screen again. So today, most of you are going to, for the first time, look at Snap and play with Snap. Anybody know Snap already of you? Not many reactions. So right behind me, I got, of course, the obligatory SAP thing. So when we talk about SAP, and when we talk about engaging the next generation, kind of, the students, this is kind of the solution that we came up with. That we say, okay, we want to, spread beauty and joy of computing, and this is what we're doing with Snap. Okay, let me. And Snap is the thing that you're going to work with today. I'm going to again share my screen. So this is where we are with Snap. Let me quickly show you. Oh wait, here it is. Snap is hosted by UC Berkeley, and what it is really is an interactive visual programming system. It runs right in the browser. You don't need to install any software like anything you've probably used this week. It is, and you might know Scratch. Scratch is using visual blocks to code, so you don't have to write code. You don't have to type code. Instead, you use kind of virtual Lego bricks to stack them together to program things. It has the easy semantics of Scratch. Some of you might know Scratch, but underneath it has pretty sophisticated semantics, those of Scheme, which is a Lisp dialect used for AI, which we are going to use it for. It's, made by us and UC Berkeley together. It's used for UC Berkeley's Introductory Computer Science course for non-majors, and that course is called The Beauty and Joy of Computing. And there's a national curriculum called BJC, Beauty and Joy of Computing. There are AP courses. It's endorsed by the College Board. It's one of the courses along, like you might know, Bootstrap. That's one of the others. Code.org has one. And Snap has been translated by a community into more than 45 languages. It's a pretty vibrant international community with 700,000 users currently who have made 6.5 million projects as per today. And the good thing about Snap, it's completely open source, it's free, no cost. Everybody can not just use it in their browsers, but also download it, also remix it, find it on GitHub, and contribute to it. So let me show you how it works. Just a quick overview. Here, what you've seen is already a Snap project. I'm going to open Snap in my browser. There is a website. It's snap.ucberkeley.edu. And when you open it, this is what you see. You can check out the projects other people have shared. There's always some interactive motto of the month that we're soliciting the community to write programs with. And what you want to do is you want to run Snap. And when you run Snap, it opens right in your browser. And this is Snap. It is a programming environment. And what you do is, usually when we do it with students, when we do it with kids, we start to draw something. So in order to draw something, we can go to costumes. And here's a little paint a costume editor. It's kind of a very simple thing. And here, for example, I can sketch a little heart again and draw something. I can fill it. So now I have a heart. And when I draw something in Snap, it's not just a drawing, but it becomes an object. I can move it with the mouse, and I can program it with these blocks. Like we have these puzzle piece blocks that do something. I can try everything. When I click on the move block, it moves to the right. When I click on go to 0, 0, it goes to the middle. So the 0, 0 coordinate is in the center of, this is called the stage. There are different categories of blocks. Here's the looks category that governs kind of the appearance of this. And for example, here's the change size block. If I click on this, the heart becomes bigger. I can also take these blocks, peel them off, and put them in here. This is the scripting area. I can also click on them in here, and the block will get bigger and bigger and bigger. Kids are going to, by the way, kids are going to click on this and see how big it gets really big. So if I want to reset it to 100%, there's a block for that. There's other categories. There's a control category where there are blocks that are kind of hat-shaped. Those are event blocks. There are little C-shaped blocks. Those are loops. Here's a repeat block that repeats something 10 times. When I have blocks and I drag them over the already existing blocks, I get little indicators where it can drop them. So when I drop them now, I made a script out of these two blocks. With these C-shaped blocks, I can also wrap them around other blocks, or I can take another block and place it into the C-shaped block. So now if I click on this, my heart grows by 100%, like 10 times. And I can attach more than one block to a script. So now I have a little script, basically one block. If I click on this, there's a little heartbeat. I could take another repeat block and wrap it around this. So if I'm repeating this twice, I get kind of a double heartbeat. And this is the way we program, right? We don't have to think in advance what we want to do and then code it up and then compile it. But the idea is that we want to do everything very interactively in a playful way. And now I could also, I don't want to click on this. I want to click on the heart in order to make it beat. So here I could take one of these event hat blocks and say, when I am clicked, I is this sprite, which I can also rename to be called heart. So when the heart is clicked, so when I click on this script is going to kind of whatever comes underneath is going to get executed. So now I click on the heart and you can see the script gets executed. So I can also kind of make the stage bigger and smaller. I can make it full screen. And if I click on this, it gets executed. So this is already an app I could, save and turn into a link, a URL, and I could send that link to somebody and they could open it on their phones and click on this and there's a heart. What makes Snap special? What makes Snap special is that we can build our own blocks in Snap. We can make any block in here that the system has. So in Snap, we have these puzzle piece shaped blocks. Those are command blocks. They are like the statements in other programming languages. They do something. We also have round blocks. Round blocks report something. They are function blocks or expressions. So we have, 3 plus 4, that is an expression. So what's special in Snap is that we can also make blocks that don't yet exist like we can make custom functions. In order to make custom functions, there is a make block button in every of these categories. I'm going to show you very quickly how to make a block. So I want to make a new block. I can first select the category, the color. I want to make a blue mathy block. I don't want to make a command block, but a function. And I want to make a function that computes the average from data. So, if I wanted to make the average of 3 plus 4, I would say, 3 plus 4, then I would divide it by 2. So now this would be the average of 3 plus 4. Now I want to make the average of any of these things. Like what if I made 3 plus 4 plus 11? I would have to say now divided by 3. Now I want to turn this into a function. And I make a new block. So when I click OK, you can see there's a block that says average data, and a block editor opens where I can now define the block. The first thing is I want to define data as an input. So I can say this is supposed to be an input. And I can say the input is supposed to be a list of things. So I have a list of things. And now I can apply this. So this is my average block. And the way how we make lists in Snap, there is a block for that. Here's a list block. And I can expand that. I could say, okay, 3 plus 4 and 11. If I click on this and evaluate this, I get a list of things. So I want to make the average of these numbers. Now, if I click on it, nothing happens. So I want to define this. And I define this like this. This is what I want to do. I want to get the sum of these numbers. So if I'm dragging this on here, I'm getting the sum of the data. And I want to divide this by the length of the list, the length of the data. So this is my very simple function. And now I'm getting the average of these numbers. And so it works with two numbers. It works with 3 numbers. It works with kind of any numbers. I can get the numbers from 1 to 100. Now I get a bigger list. I can put that in here. And that also works. So we've just made ourselves, I've just shown you how to make a function, and we can make any function in Snap. There's another kind of powerful concept when we think about this, is that now I made a function that makes the average of a bunch of numbers. We can use this for other fun things. Let me import a little sprite here. So here's another heart. And if I click on this, I get a beetle. And now this sprite that I've drawn, it can sense things about its environments. For example, I can see my other sprites. If I click on this, I get a list of the other sprites as kind of this heart sprite and this bug sprite. I can also find out other things, like I can find out the position of, this other sprite. If I click on this, the position is a list of two numbers. That's the x coordinate and the y coordinate. So if I get my other sprites and I get the position of my other sprites, I get a table. And a table in Snap is really just a list of lists. It's a list of two-item lists that are the x and y coordinates of these other sprites here. So what if I wanted to get the average of this? It's a list. I can put this into my average block. And what I'm getting now is the average position, the average of these two lists, which is again a list of two items. And that's interesting because what we're doing here is we're extending the domain of operators to not just work with scalar data, but to work with data in any form, also vector and matrix data. So I could, for example, tell my heart to go to the average of the position of these other sprites, and watch what happens if I click this. It goes to the center, to the centroid. And that's kind of fun because I can now do this forever. Remember, Snap is always live. So now this heart is always going to go to the center. So if I drag these and move them, the heart is always assuming the center position. And if I add more sprites to this, like now I have a frog, it'll go to the center of these more sprites. That's a powerful concept. I hope you see that, in Snap, we try to do things easy. We try to make things live so we can always play with them. The special thing that distinguishes it, that sets it apart from other blocks-based environments, is that we can build our own blocks and that we have very powerful ways to deal with data. Let me show you one more example because it's going to be relevant for our surprise guest. One thing that we like to explore in Snap is media. So one thing that when we engage students with is, for example, pictures. And it's always nice to have, a picture of yourself in the program. So I can take a picture of myself. I'm going to make a picture of myself. I'm going to raise my arm and go to my right. I'm going to take a picture. I'm going to raise my other arm, move to the left, and take another picture. So now I have two pictures, and I can switch in between these two pictures. In fact, let me take that back to the center. And I can also explore these pictures. So I can find out something about these pictures. I can find out here's a picture, the picture called camera. I can find out the width. I can also find out the pixels of this picture. And the pixels of this picture is a long table of 172,800 rows and 4 columns. Those are the RGB and alpha channels of that picture. So this is a pretty big, giant data structure of numbers. And see, there's another picture, the picture of the camera 2. That's another giant table. Hey, I told you that our functions work with data in any form. What if I take the average of, the pixels of the one picture and the other picture? So remember, this is the very simple function that we made that just makes the sum. So now I'm doing this. I'm getting another single table that has the average of every number kind of these two things. And now watch what happens when we actually look at that. So when we actually now visualize the average of two photos. So I'm making the average of two photos. See, I'm actually getting them both inside one photo. So this is a very powerful abstraction that makes us be able to deal with huge data sets in an almost naive way. And I'm just showing you this because that'll come in handy when Mark Guzdial visits it, because Mark Guzdial is the kind of researcher that invented this kind of media computation, or what he calls this. I'd now like to hand over to Yadka for an introduction of what we're going to do today.
Okay. Hi, everyone. Thanks, Jens, for the great snap demo. So I've seen this several times, and I still love it. Every time I see it, it's just like it's really the best programming language. I love Snap. So what we're going to do today, let me share my screen as well. Can you see my screen?
I can.
Great. So perfect. Let me open a new window. Okay. So what I'll show you in a minute is the learning module, the teaching resources that Jens and I came up with in the last year, and it's called Grand Gestures, and it's about a gesture recognizer. I first want to show you where you can find the resources, and they are at this URL. I'll post it in the chat later. I'm having issues finding the chat while I share my screen. But if you scroll down to Learning Experience, and then you click on the Module 7 Grand Gestures, this will download a zip file containing all the teaching resources that we need today. Here they are. And it's 7-ish worksheets that you can hand out to your students. It's an introduction for teaching, for teachers, and it's a few additional material, and I will go through it with you in a second, but let me explain a little bit more about why we did all that. So we did that together with the organization called the Wissensfabrik, which translates to something like Knowledge Factory in English, probably, and they do outreach in STEM topics in German high schools. And since AI is, as you know, a pretty hot topic right now, they wanted to create teaching resources for high school students and also young adults to learn about AI, understanding where AI happens in our everyday life, and also to be able to build stuff with AI themselves. So we have all these modules. The first two are pretty basic, and they show you where you can find artificial intelligence in everyday life, and how speech recognition works, and how you would interact with something like Siri or Alexa. And then we have several modules that explain several concepts of machine learning deeper. So there's 3 large groups of machine learning: reinforcement learning, supervised learning, and unsupervised learning. And you can explore these a little deeper in an unplugged version in Module 3. And in the plugged version with your computer using Snap in Module 5, the Banana Hunt. And then we have 2 other modules that explore the idea of data analysis a bit more. And the last one, that's the one that we're going to do today. And it's called, as I said, Grand Gestures, but feel free to check out the other modules as well. As I said, the Grand Gestures module consists of several of these documents, one of them being a module description. Let me open this real quick. So this is a 18-page document that explains different things. For example, why did we even make this thing? What's interesting about gesture recognition, it also contains a lesson plan. This is, of course, aimed at high school students. So if you want to use it on university level, you might need to change this a little bit. But as Jens already mentioned, this has also been tested from Mark Guzdial at university level, and apparently it did work. So we're really looking forward to you exploring the ideas as well. Okay, and let me scroll through this a little bit. As I said, we have an introduction. Why did we make this thing? Then we explain a little bit what is gesture recognition. So it's a division of computer science that wants to interpret gestures in a 3D or 2D environment that you could either draw or that you can make with your body. And you use them for HCI, which is human-computer interaction, so to control computers or computer programs. And then also we explore Snap a little bit and tell you what Snap is and what's interesting about it. And we have, as I said, the lesson plans as well as a few further additional resources for learning Snap and for reading about the gesture recognizer. The gesture recognizer that we're using in this module is called the $1 gesture recognizer. It was developed by researchers at the University of Washington, and it's aimed at rapid prototyping. So this is a pretty simple 2D unistroke gesture recognizer. So that means you can only recognize gestures that are drawn in one line, basically. And they developed it so you can prototype gesture recognition in apps really fast. The cool thing about it is that it needs very few examples to actually get a pretty precise result. So it's a reasonable amount of training that you can do in class. And also it's so simple that you can build the whole thing in your own lecture, workshop, project group. So that was really important for us that we select something that the class can get the whole experience. And this is also what was really important for us developing the whole module. We wanted students to get the whole experience of building the artificial intelligence, training it, testing it with a few test cases, then refining it if it didn't work, and then also applying it. And also we wanted this to be a very creative approach. So our idea is that, as Jens showed in the beginning, we use our gesture recognizer to tell stories later on. So let me go real quick through the different worksheets that we developed for students. And so you can see how one of these, how you would use this module. We start with a simple intro to gesture recognition in everyday life. So how do you use it? Where do you use it? What are gestures even? So for example, if you're a diver, you know that when diving, you can't talk. So there's a lot of gestures that you can use. Also sign language is kind of gesturing. We all know swiping from our phones or pinch zooming. Those are all gestures that everybody of us uses. And we either use them to communicate with other people, or we use them to control our computers. What's cool about gesture recognition, and then students are supposed to talk what could be the advantages of gesture recognition. One of them being you don't have to read. They work on different devices, so they work across different devices. Everybody knows them. So that's pretty cool. What's not that cool is that, for example, people with motoric disabilities might not be able to use them. And this is what we're trying to explore with this worksheet. In the next one, we dive into building the gesture recognizer. And the first step, of course, is we need something where we can record our gestures. And this is also will be our first programming task. We'll create a sketching program which will help us to draw single stroke gestures. Here again, you can see the difference between a single stroke and a multi or Multi-stroke gesture, so single stroke means you draw everything at once in one line. Multi-stroke means that you need to lift the pen in between, so we won't be able to draw that with our sketching program. And then we'll program that using Snap, and Jens will lead you through that in a bit. Sorry, I'm at my parents' place and they didn't know that I have a workshop. Okay, so the next thing that we're going to do, and we do that after Mark Guzdial visits, is we want to animate our sketches. We're not there yet recognizing them. We just want to have the drawings and we want to animate them. We built a block for you that you can use to do that. So you can see that block here, and I will send you a project later that you can use that contains this custom snap block, and then we'll create several animations to a few of the drawings. So for example, we can, like Jens just showed you, we can make the heart throb, or we can make a star blink or something like that. So we'll explore a few animations. In the next step, of course, to recognize a path, we need a way to compare paths with each other, or we need to compare a way to compare drawings with each other. And the way we want to do that is we want to record paths. So we want to record the positions of our pencil while we draw things. This is what we do next then. So we will make a variable that will, whenever we move our mouse around the stage to draw our sketch, it will store the position in that variable. So we then have later a path that we can use to compare it with different other drawings that we made before to find which one we're closest to. So what could be the one that we just drew. And the next step then is to compare these paths. The problem with that, and that's a pretty cool idea, I think, is that you can't just compare the paths with each other, because when you think of, you draw something very slowly, you will get a lot of points in the path compared to when you draw something really fast, where you might only have 10 points. So if you compare these two, they will be very, very different, although they might represent the same gesture. So what we need to do here, and this is I think the most interesting idea in the whole module, is we need to normalize our drawing. In the original $1 gesture recognizer, there's several normalizing functions, one of them being resample, and this is the one that we're exploring here. The resample block that we will also give you resamples a path to the number of points that you indicate here. So for example, here you can see it with this example. And as you can see in the drawing, at the beginning, we have a lot of points, then we drew something faster, so there's fewer points, and then here we have a lot of points again. And what the resample block does, it distributes the points evenly along the whole path. So this is one form of normalizing that we'll show you today. There's also others in the $1 gesture recognizer, like scaling. So you want all paths that you compare, or all gestures that you compare, to have roughly the same size. You might also want them to be roughly at the same position, so translating them is one of the other normalizing functions. And the last one is rotating. Them into the same direction. As I said, we only will use the first one, the resample one, but we will show you a project that contains all of them later. And then, right, I forgot to talk about the recognize block. And then we will use this idea to make a recognize block. So this recognize block will take one path, one sketch, the path of a sketch, and a list of a bunch of examples. So we will train our project to contain several examples, and the recognize block will find the example that's closest to the sketch that we want to compare it to in our whole list of examples, and it will report this result. So this is the whole thing that's happening in the recognizing, and it's using a nearest neighbor algorithm. And also this is a form of machine learning that's it's supervised learning. So we're learning from a labeled input. We have data that's in each data point has a label, and we learn. Could you mute yourself? Or could someone else mute them, please? Thanks. So we have labeled data, which means each of our data points also is connected to a label, and later on we can in the testing phase we can find out whether our new testing data gets the same label from the algorithm. So that's how that whole learning process works. And in the last step, we want to use this thing to tell stories. So we want to, and we'll show you that later. Snap has the possibility to broadcast messages. So when we recognize something, we want to broadcast that to the whole project, and we want these specific animations to react based on which of the messages they received. So for example, when we recognize a heart, we will broadcast the heart message to the whole project, and then the script that has the heart message in it when I receive heart block will react. So whenever we broadcast heart, the heart script will be triggered. Whenever we broadcast drop, the drop script will be triggered. Whenever we broadcast star, the star script will be triggered. And we can use that to tell stories. That's all the programming that we will do today. And then hopefully we have time to do a reflection. Because our program obviously has some limitations, we left out a few of the normalizing functions, so we can definitely try out why we need them and what happens if we don't have them. And also other things that Jens and I found out accidentally because he's right-handed and I'm left-handed, and it was really hard at the beginning to use each other's program because we draw things differently. What could we do to take care of that? And we might have time to discuss that a little bit. And that's the whole module and all the teaching materials that are available for students. For educators, we also have available 2 more things. We want to explore with you how you can save and share projects in Snap. This might be handy for also sharing your projects with the class. So if you prepare something and you want to share it with the class, you need to know how to do that. And also if you want your class to present something in the lesson later on, you might show them how to share projects with you. So that's interesting. And also, most of school teachers know Scratch in Germany, but Scratch and Snap are a little different in a few important cases. And here, for example, in this blocks in Snap glossary, we explain blocks that we have in Snap but don't exist in Scratch. If you don't know any of the programming language, that might not be particularly useful, although we also explain how the blocks work. That we used in this module and how you can make your own custom blocks. Jens just showed it to you already, but here just to go through it real quick, you can click on the Make a Block button. Then you can name the block. You can decide which kind of block it's supposed to be. This is how the block editor looks like, blah, blah. So we did all that. But if you need help doing it again, you can find that here in this blocks in Snap additional material. And also, as I mentioned, we explain all the custom blocks that we use in this module. The animate block, for example, that's what its script look like. That's what the blocks look like, what the block looks like. And here we explain what the block does. In this case, for example, it takes a drawing and turns it into a costume for your object, so you can actually animate what you've drawn. And we do that for all the custom blocks that we have. If you need, either if you get questions or if you're interested yourselves. And finally, we also do have a sample solution. So for all of the worksheets that we have, all of the programming exercises, if you get stuck at some point, you can take a look at the sample solution. Here we have a step-by-step solution. So this is, for example, the solution for the sketching program. And we also, although I urge you to please try it yourself, we also do have links to Snap projects with the complete solutions. So if you get stuck at some point, you can check out the sample solution. Okay, so that's all I wanted to tell you about this module, and I'm sharing the link now as soon as I unshared my screen, and Jens will now take you through. Yeah, and the download link, and Jens will
already
now
shared that. Yeah.
perfect. Thanks. Jens will now take you through the first programming steps if you don't have any questions. Also, by the way, if you have questions, unmute yourselves all the time. Feel free to ask them.
Thank you, Jitka. So now you've kind of been overwhelmed with information, and now we're going to try to actually have some fun and dive right in and do something. So please, everybody, if you haven't already, click on the link that I've shared in the chat and just download the materials now. You can open them in another tab and look at them. You're not going to need them for the session, but we want you to have them because it's basically the material that's ready to use for you in class. You know, any class that you want to teach, you could just use this material. And so now what we want to do is we want you to open Snap and start programming. And for this, we want you to, we've prepared a little project that already has some of it actually has all the custom blocks in it that we need for the project. And this is because we want to make it easy for you to get this experience. So there are several ways in which we can use it, like we can build everything from nothing, but then it might take a little longer. So we've designed this course, like if you do this in school, we've designed it to be 3 sets of double periods. Today we don't have that time, so we have a project that is this link.
I already posted a link to it to the chat.
Yeah, that's the link Jitka just posted. Please click on this link, and then Snap should open in your browser. Now it's important that, I don't think I have to say this anymore, nobody uses Internet Explorer anymore, right? So any browser will do, I think, as long as it's a current browser. Yeah. I'm going to share my screen now, and wait. So now, of course, I can't click on the link anymore, so I'm just going to open it. Wait. That's the module.
I also published it, so you should find it on the Snap front page, maybe.
You published it. That's great.
It's called something with all blocks.
Wonderful. Okay, so I'm going to open this now. All blocks, the tinyurl.com/grandgestures all blocks. So what you see is basically an empty Snap that already has the title, kind of Grand Gestures Starter all blocks. So the first thing you want to do is you want to save this. You want to, if you already have a Snap account, you can save it to the cloud. This is, you can just sign up. It's free. It's unlimited storage. If you don't have a Snap account yet, don't worry. You don't need one to use it. Also in school, you could just open Snap the way it is now, and then you can say export project, or you can say save as. So if you already have an account, you can say save as, and I'm going to say, storytelling. I'm going to give it a name. You can give it your own name, storytelling with AI. I'm going to say save. And now it's saved to the cloud. If you don't have a cloud account, you say export project. And what it does, it'll save this project, to your download folder. I'm going to do this now. So now you're going to see at the bottom of your browser, you're going to see this thing that says, whatever you called it. And it's also in your downloads folder. If I go to downloads, you can see here is my storytelling with AI. It is an XML document, which, if you double click on it, you're not going to see much, but you can open this again. So if I go to another Snap, open Snap again in another tab. You can either drag it in here from your browser, or you can open it, in your Explorer or file viewer. You can drag and drop these things and just drop them into the Snap window, and that'll open it. And you're again going to have all the custom blocks that you need and everything you're going to add to this project. So please save often, and also export often. It'll make a new version of it, which is great, because then when you get stuck or when something goes wrong, you want to revert to another version, you still have what you worked on. So the first thing that we want to do for this project is really an activity that we like to do, even if we're not doing this particular project. It's a really fun first thing to get into the hang of programming and to do something that doesn't just compute something, but lets us already do something creative. We want to make a little program, a little drawing program where we can draw something ourselves. And in order to draw something, we want to, draw with the mouse. Okay, so when we draw something, the way what we want to do is we want to start, when we press the mouse button somewhere, we want, this thing to follow the mouse. And when the mouse button is down, we want it to draw. And when we lift the mouse button, we want it to stop drawing. So for this, what we can do is we want to first, here in this part of the Snap IDE, we see two buttons. You see a button called Stage and a button called Sprite. Sprite is active. If you click on Stage, you see now Stage is active. And this side changes. So you go to Stage, and we want to define a start block. That's an event block when something will happen. And so we program each object in its own area. So we click on the stage. Stage is kind of the background. And then I'm going to show this to you step by step, and I'm then going to pause to let you do it. So go to stage, go to the control category, and we want this thing to start when something happens with the mouse. So when I am not clicked, but when I am pressed. The difference is clicking means the mouse button goes down and up again. Pressed means the mouse button just goes down. And so when I am pressed, so when the mouse is pressed anywhere over the stage, something is going to happen. Like I can say, wait 1 minute. So now when I press the mouse button, you can see this thing fires. I don't want it to wait. What I want to do is I want it to broadcast something, another event. Broadcast means it sends a message to everybody who is interested, every other object. And I want to make a new event. I can do this by clicking in here and saying new. And I want to have this new event that is called sketch. It's kind of the name of the program we're going to write. And now nothing is happening, but this is the first thing you're going to do. Go to the stage and do this. And in fact, everybody do this right now. Drag out these two blocks and you're going to write your first script. That's not going to do something, but this is kind of your first little 2-block script you're going to build. Please do so now. Okay. Once you have this, it's not doing it. Let's actually make it do something. So now we want to go back to the sprite. Again, click on the sprite icon. So now we're again in sprite. You can tell that you're in the sprite scripting area. And now we want to make it react to the sketch event. And that's another hat block. It's called the when I receive hat block, the event hat block. We're going to drag this out. And now if you click on the kind of, drop-down menu, you should see the sketch event that you defined kind of in the other script, and you can select the sketch event. So now when I receive, you're going to select sketch. And then we're going to make it draw something. And in fact, so what is that going to be? First, let's look at the blocks that make us draw something. Those are in the pen category. The pen category is up here. The pen category has a bunch of useful blocks for drawing, and we're going to drag them out. One is going to be clear. Clear basically erases everything we've drawn, so we want to use the clear block. We can also put the pen down, and we can put the pen up. So we're going to need these three blocks. So we're going to drag them out. And then we're going to go back to the control category and do something. So when I receive sketch, we want to clear it. And then what we want to do is we want to repeat something. We want to repeat something until the mouse is no longer pressed. So we're going to say until, and we can say something is not pressed. The mouse is down here. That's in the sensing category. We're going to repeat something until the mouse is no longer down. And what are we going to do is we just want this thing to follow the mouse. So in order to follow the mouse, we have a go-to block. So here's a go-to block. It says go to random position. If we click on this, the sprite goes to random position. Well, we want to make it to go to the mouse pointer. We can select that. Now we can already try this. We have it in here. So now if I place it here, if I press my mouse, now the mouse is following, the sprite is following my mouse until I let go of the mouse, then it's no longer following it. So everybody kind of built this thing like right now. When I receive sketch and in the sprite morph, in the sprite scripting area, build this little script. It doesn't yet draw anything. So what we now want to do is when we go to the mouse pointer, after we go to the mouse pointer, we put a pen down there. And when everything is done, we put the pen up underneath the repeat block. Okay? And now try it again, because now what it should do is, look at this. We should be able to draw something. And when we let go, we stop drawing. Okay, so we need to be careful where we place these blocks. So this might seem a little bit strange. First, to the mouse pointer, then we put the pen down. So we would think that we wouldn't see anything. But you know, this is going on all the time. So we're really just skipping the very first point. And so now if I'm doing this again, and if I'm drawing something, so now I'm holding it down, you can see, and I'm moving it, and you can see it will always put the pen down, but since it's already down, it doesn't do anything else. And if I let go, then it'll lift the pen up and it won't do anything anymore, right? Does that so be careful to put the pen down inside the loop after you go to the mouse pointer, and the pen up at the bottom of the script, and then you should see a line.
Okay, maybe for everyone, because that seemed to happen more often. The pen down block is just setting the pen down when you click on it. And if you click on it once, even not connected to the rest of your code, it will put the pen down. And then whenever you move, it'll draw. But as Jens explained, you also might want to put the pen up in between, because it will also draw the line to the new position when you click again. And we want to avoid that. So
this is kind of already fun. What I love about this thing is, you know, it's a rather simple program. And the fun thing is not every kid, not every student will draw the same thing. You know, somebody is going to draw a house. You know, others are going to draw, you know, all kinds of things. You know, they're going to draw their names, right? Um, and and this is something to get, you know, also oneself into the program, kind of your own creativity. So this is the fun thing really about this AI thing, is that, you know, handwriting, hand drawing something is very personal, and we want the computer, the AI, to interact with, you know, our personality, with kind of how we draw, how we do things. And that's kind of the beauty behind gesture recognition. We can now make this a little bit more beautiful. um for example, I love to make the line a little thicker, so I could say, you know, set the pen size to 3, and then you know, this is going to be uh, better visible. And another thing that I personally like to do is I like to hide this thing here, so we don't see this sprite at all. We find hide in the looks category. At the bottom, there's a hide and show block. Um, we hide it, we don't see it, but it's still there. So now we can show it again. Then it's there again. But if it's hidden, we can put the hide block here. So now it still works. You know, I can still draw something. I can draw an error, um, or I can draw a flower. Still works, and now it appears as if I'm drawing with my mouse, but in fact I'm drawing with a sprite, but it's hidden, it's invisible. So maybe you want to try this, and be sure to save your program once in a while, so in case something crashes, you don't get lost. This is already a full-fledged program, right? You can try this. You can you know, use this in full screen mode and do fun things. Remember, you can always only draw things in a single stroke. Why is that? Like in the materials,
Because we have the clear script written and added to ours. Every single time it
exactly,
executes, it deletes them.
exactly. So if you take out the clear, which you can disassemble it, take out the clear. If you do this, now I can draw, can add other things, which might also be nice, right? So this is how you could build a program. But now, how are you going to clear it? We could make it, I'm just showing you, we could make it that, you know, if you press the space key, it clears. So now I'm pressing the space key, it clears, and I can draw something else. Now I can also draw things like where I can print, you know, stuff like that, which I couldn't, right? These would be multi-gesture sketches. But in this program that we want to do single stroke gestures, because those are going to be handled by the AI program that we're going to write. This is why we put in the clear right at the beginning of this script. So we cannot do this, but we can only do single stroke gestures. So if we were going to write something else, only while the mouse is down. So just to show you, you can write, you can easily turn this into a program that lets kids, you know, make real drawing programs where you can let them, you know, have other scripts that react, that make the line bigger or change the colors or stuff like that. But this is just the simplest way how to draw a single stroke gesture. So be sure to save your program and to export it often. Now, folks, I'm totally stoked. I'm totally psyched because somebody has entered the room whom I have kind of promised that we'd get, you know, a guest appearance by our good friend, the awesome Dr. Mark Guzdial, professor at University of Michigan. Yay, woo! Mark is, I don't know whether you know Mark. Mark, for those who are computer science educators, Mark is like the computer science educator. His blog on computer science education, Guzdial's Take, I think is how you named it, is like the premier source of wisdom, I think, for most of us. It's like almost the most official publication there is, kind of. Mark has been doing this for decades. For many, many years, he's taught at Georgia Tech. Mark is really the inventor of not just the pedagogy, but also most of the technology of media computation. Um, he is really one of the world's best programming educators. He has taught me a lot of programming that I know. I learned Smalltalk by following and reading Mark's books on Squeak that he wrote. Um, he is now at the University of Michigan. Mark, a couple of years ago, he has gotten kind of one of the most prestigious awards, the Karlstrom Award for Outstanding Contributions to Computer Science Education from ACM 60 for his work on media computation. I'm totally happy to have Mark agree to, kind of delight us and enlighten us on his experiences with Snap, and particularly with this thing that we're doing with you right now. That is the media computation, not media, that is the AI, kind of the gesture recognizer. Welcome, Mark.
Thank you, yes. Thank you both. Good to see everybody. Edgat, could I have permission to share screen?
Oh, wait, can I give you permission to
Jens is the commander of this.
I'm the commander. Wait, how do I do this?
Okay.
Meeting
Jens,
info,
I could have
meeting
that
options.
capability, please.
Who can share? Who can present? People, everyone can present.
Because I've got my share button is grayed out.
Can you now try again?
Now it just changed me. Okay.
Hey, wow, look at this.
All right. Let's see. How do I do
So
this?
it does work for a few things.
Okay.
It
Have you
does.
used Teams before? There's a share button at the top right.
Yeah, I'm in that. I've got that. Interesting. Okay, so I'm going to share screen window. Okay, do that. And there we go. Okay. And you can see my slides?
We can.
Yes, we can.
Yay! All right. Let's see. How do I make that go now? All right. There we go. Oh, and let me put this in the chat. I think I saved this URL. Bloop. Yes. Okay. That's where I put links to everything that I'll be showing you today. Okay. Do that. Do that. So this is the class where I have been using grand gestures. It's Comp 4. We have a brand new program, and I'll tell you a little bit about that later. It's the program in computing for the arts and sciences, and Comp 4 is our course code, and it stands for Computing 4. So the idea is that we are not just teaching computer science, we're teaching computing for other things. And this is the course on computing's impact on justice. And I was really fortunate to get connected with Anatoly Fandrik at the University of Oldenburg, and Anatoly gave a couple of guest lectures, and he worked with Yadga and got me the grand gesture stuff, so I was able to use it in my class. So I'm going to show you a few of the slides that I actually gave students, what the homework assignment was, and then how I used it later as well. So I had students working on a recognizer homework. So you all just saw code like this, where I told them about how they were using this code except for the very last block for being able to draw gestures. And then I had them connect in the broadcast block to be able to recognize. And then I pointed out to them that it's always going to return something, the closest match, even if it's wrong, in the sense of it wasn't actually what you were trying to create. And then I showed them the various gesture responses that were already built in, and then we talked about building other ones that they could build. The assignment, and then I had everybody in class teach your recognizer one new gesture. And this was great to do in class because I told them to make it work for others. So everybody's handing their laptop to one another. Here, you go try to do a square. And I heard lots of, you make a square like that? Why would you make a square like that? And which is great to get people thinking about all the different ways in which people could do things. I had them use both left and right hands. So I gave them about 10 minutes. They were all working at tables to do this. And then we had a big discussion about what makes the recognizer work, what didn't work. For example, we found that if you tried to recognize a square and also tried to recognize a circle, that was really hard, because if you just have a large area like that, it was really hard for the recognizer to recognize a difference between them. So we talked about what happens if the shapes are close together, what happens if your examples conflict. So I also talked to them about, you don't have to keep all of the gestures that are already in the recognizer. You could delete all of those and start over again if you found that you were getting close matches to something else. And then we talked about changing left and right hands, drawing in one direction versus the other. And then I gave them a set of blocks as an examples for how they could manipulate the training set. So before I gave them the Grand Gestures project, I saved all the original examples in a separate variable so that they could always get back to the original examples if they wanted to, but they could also delete all the examples if they wanted to retrain it. And so that gave them some flexibility in what was actually in their training set. So this was the actual homework then that I gave the students, that they had to train the recognizer to recognize 3 gestures, but I was going to be the tester. So they had to think about and some of the students said, would you try this so I just know whether or not it'll work for you? And sometimes I did. And what the funny is how often it didn't work, right? They didn't have enough gestures trained yet so that it could understand me. And they're doing it like, okay, you shouldn't make it like that. Make it like this, and they're trying to coach me along. So a big part of it was that they had to give me text that I could understand, instructions, so that I would make the gesture the way that they wanted, that I understood what their gesture was. So here's an example of an assignment built around the Grand Gestures project that you just saw. I'll pause there for a minute before I go on. Are there any questions for me on how I use this in the class?
No, but I love this.
Yeah,
We
that's
should
really
add that.
neat.
We
It's
should add
awesome.
that, totally add that
Yeah,
to the
that's a
things.
wonderful idea, Mark.
What's
So
the
then-
practical application of these in real life?
What is the practical application in real life?
Yes.
It wasn't meant to be that I expect them to be able to train gestures like they would make on an iPad or a touch screen. It was more about they recognized that recognizing a gesture was a recognition system. And we talked a lot in class, and Anatoly did a particularly great job of it. There's a whole set of slides that the group in Germany has been setting up to talk about how gesture recognition there's a metaphor to be made about how facial recognition works, or even how speech recognition works. So the gesture recognition was one way of making it very accessible to students. What does it mean to create a training set? What does it mean to recognize a gesture and then to respond to that gesture? Does that help?
Yeah, it does. What's behind my thinking is I'm a business professor, and I'm thinking of how I can use this to create gestures in the business context, so that maybe to affirm a customer, encourage a customer to continue to dive through options that are presented to them, and so pretty much like an emoji-like gesture. Response to customer inquiry, customer interest. But maybe I'm thinking too much outside of the box.
No, I think that's really great, but I would probably talk about those things as implications of what the students are doing. So I can speak a little bit about, so who's taking this class, Guzdial? This is kind of a weird class, Computing's Impact on Justice from Text to the Web. It's a new course in our Liberal Arts and Sciences College. So I actually did have business students. I actually had a few CS students, but I had a lot of students from all over the university, psychology students, communication students, music students. And so these were students, and it's an open question for us. So why did they take this class anyway? And it's actually an area of research. I have a student who's been doing interviews with these students to understand, so what are these folks after? For most of them, they didn't want to take a traditional computer science class. They don't want to become software developers, but they wanted, for example, to develop what's called conversational programming ability. They want to be able to have a talk with a programmer, know what their tasks are, understand what their language is. So after doing the gesture recognizer, my students could talk about a training set. they could talk about the task of recognition and how recognition is a heuristic process. It isn't one-to-one. It's going to be complicated to make a match between a particular gesture and the training set. And that's the kind of conversations I wanted to be able to have with these students.
Okay, thank you.
Sure. So that was the part where Anatoly gave a lecture on AI, a lecture on machine learning, and then I did this one, which was introducing the homework, which was more hands-on. A couple of weeks later, I wanted to talk about the topic of generative AI. And I was able to use the gesture recognizer because they'd had that experience. They'd trained the recognizer, they had done this homework. So I asked them, who generates generative AI? And I talked about their gesture recognizer and the fact that they could have all of these various gestures that they had trained, that they had associated with some sort of a key phrase. And I talked about being able to render these and now trying to generate new sketches from this. And the idea was that we could say to them, what if you averaged all the propellers? What you'd get is now a new propeller. But it hadn't been drawn by anybody. You'd averaged across the things that somebody actually had drawn. And then I extended the metaphor. What if you averaged a heart with the propeller? And now you're defining a completely new shape that nobody had drawn, but it was based on gestures that somebody had drawn. And you're trying to mix and match based on the gestures that are there. So then I gave them this small piece of code that, given a name, would average all the sketches with that name and then allow me to render it. So this, for example, is an average rendered star. Nobody actually drew the star like that in my training set, but it's based on what other people had done. That's sort of the idea of generative AI. The generative AI is going to take a bunch of data that it's gathered, in our case, the training set data, and then build something new from that. But instead of recognition, it's now doing generation. Okay, I'm going to pause there. So this isn't a lot, but it allows me to build on what the experience that the students have had already to link to these idea of generative AI. And so then we can talk about, like, how does ChatGPT work? Well, it just gathered up all the text that it can find on the internet and now can generate new text for you. But it can't talk about something completely novel because it's only based on what's gathered up that's out on the internet. I'll pause there. Questions? All right. So Jens had asked me to talk a little bit about, so what is this new program and what are we doing and how are we using Snap in these courses? So in September 2020, my colleague Gus Everard and I, he's a physicist. He actually has one of the coolest job titles in the world. He is a computational cosmologist. He actually simulates the Big Bang. It's very neat. Anyway, we were asked to figure out, what does the College of Literature, Science, and the Arts, the liberal arts and sciences folks, what is it that they need in computing? What kind of computing education? And separate from whatever computer science or our School of Information was offering. And what we came up with is this idea that in the liberal arts and sciences, computing is organized around three themes. One is computing for discovery, all this idea of computational science, making new things. One of the things that I learned in talking with all these folks is that computational science is not the same thing as data science. Data science tends to take a great big what's there. Computational scientists start out with a theory and then develop a model and then use that for whatever they're going to do with computation. These are humanities people in liberal arts and sciences. For them, computing is a new form of expression. So where humanities people study a lot text and now today film, now it's all about computation and how do we engage with others and how do we communicate with this new media. And the third one is this notion of critical computing or computing for justice. How do our systems have biases and exacerbate inequities? And that's where my Computing for Justice class is coming from. So our program was just launched this summer as of July 1st. It's Gus and me. We're the whole faculty. We are the entire department. So I have the best department chair job in the world. I am the department chair of absolutely nobody but myself. It's great. Our goals are to eventually meet the needs of all LSA students around computing education, to create new courses, to create new programs and credentials. So we currently have these two courses, the Computing's Impact on Justice and Computing for Creative Expression. Literally, we have just submitted 2 weeks ago our proposal for a new course, Introduction to Python for the Sciences, and another course on the transistor disruption, how computing impacts science and society. It's going to be really cool. They're planning to use Danny Hillis's book, The Pattern on the Stone. So very neat stuff. So let me say a little bit about how I'm using Snap. Snap is core to this class, but there's stuff on either side of it too. So we start out teaching with these things that we're calling teaspoon languages, which are teeny, teeny, tiny programming languages. They really are programming, but they're incredibly small. So for example, here's one of them. This is for pixel equations. This is related to the media computation stuff that Jagda and Jens have been doing. So the idea is that you can select pixels by putting in some sort of a Boolean expression, and then define how you want the color to change. So here, everywhere where X is greater than 200, we're setting the red to 255, so it becomes very red. And we can do formulas in here. So we could say 255 minus rojo, minus the current value of red, minus the green. And now we're going to sort of invert everywhere where X is greater than 200. So I have students starting out the idea of how do you manipulate pictures and thinking about, well, pictures actually have pixels and they have a red, green, and blue component, and I can manipulate the red, green, and blue component. Can I use equations for that? We're doing all of that in this really simple teaspoon environment. We also have some other teaspoon languages that we've been building where students can do sentence recognition and sentence generation based on parts of speech. While this is incredibly simple, you might even argue this, is this really programming, Guzdial? It's enough that you can get to debugging situations. If you type NON instead of noun, it's not going to match to anything. Or if you thought, well, wait a minute, lazy dog runs to the house quickly, it should recognize that house is a noun. Well, not if it's not in the dictionary. So that's relating this idea that an algorithm is intricately connected to its data in order to be able to execute. After we introduce the idea of teaspoon, and we only use the teaspoon languages like for a single lecture period, so like 30, 45, maybe 60 minutes, we then start doing the same sorts of things, but in Snap. So on the left, you can see one of the examples. We give them a whole bunch of custom blocks. We've built lots of custom blocks so that students, if you look at the thing on the left, that looks a lot like what they were manipulating the teaspoon languages. The basic notion about how you're manipulating the pixels is the same. The one in the middle is based on a set of blocks we give them that's like the sentence recognizer. But now we're going to pick out words at random to generate phrases. So the idea here is that how does a Twitter bot respond to you? So this is looking for, it's going to say something negative about the yellow party. There's a green and yellow political party in this world. It's going to wait for a tweet back that has a green noun in it. And then it's going to say something positive about the green noun. And the right-hand side is actually where I take the Titanic example that Jagda and Jens have done in the past, but I'm building a set of blocks to make it look a little bit like SQL. Because then at the end of the course, at the end of each unit, I give them a ebook activity where I say, here's Snap code that you've used before. Here's now Python code that does the exact same thing. And we do this with things like HTML. We do things like the media computation so that we get students making connections. Okay, I did this in Snap. I see how it's done in Python. I can answer questions about the Python. I'm not asking students to learn Python. All of their programming assignments are in Snap, but they're getting the opportunity to connect their Snap knowledge, to transfer it into textual languages as well. So I care about conversational programming. I care about self-efficacy. I want students to come out of this saying, oh, yeah, I get what this is about. I want to be positive about this. And then I want them to learn a set of concepts, but not necessarily traditional computer science concepts. I don't really care how much they know about, I'll actually go there. I don't care about them knowing about lists all that much, but I care a lot about them knowing about there's training sets and there's recognizers and there's biases that get built into software. So let me give you a couple of examples, and I'm hoping that this is going to work. So these are movies that we've made from some of the assignments that students did last semester. So the very first assignment, in fact, my students are working on it right now, is they have to make me an image collage. And this is in my Computing for Creative Expression course, where we actually look at artists' work. We look at how artists have made art with simple basic shapes, and then I ask them to build something as well. This one, I'm hoping, okay, I'm hoping this works because this is an audio one. When we get to the audio stuff, I ask the students, the homework assignment is, can you hear it? I asked them to paint me an oral scene to make it look like some world. And so here this student was trying to make it sound like a subway. And if you notice what they're doing here, it's really cool. They use a train sound at the top of it, the sound coming in. They're increasing the volume as the train is coming in. And then as it's leaving, they're decreasing the volume, multiplying by 0.3 and then by 0.1 and playing it backwards. It's a negative rate. And by playing it backwards, you get the sound as the train is going away. This is another one. This is one, it's meant to be a haunted house. And there we go. I think that I'll probably stop there because at this point I was just generally going to show the Titanic example, which Jagda and Jens can do way better than me. So I'm going to stop sharing here. And as I mentioned, that link, I'd link up to the Teaspoon languages, to the ebooks, to a lot of the Snap projects we're building. One of the things that we're doing right now in the class is I'm having them build chat bots in Snap. And then using the cool reflection features in Snap 8.0, I created a tool that would convert from Snap into this web-based Charlabot language. And then the students are then programming the same chatbot. And it allows me to talk about, here's the chatbot in Snap, here's the Charlabot. They're doing the same thing. That's an algorithm with two different program representations of the same algorithm. And we can even talk about things like how compilers work, that's essentially what I'm doing, that I'm translating from one form into another form that I can then use in a new purpose. So stop there, happy to take questions.
Are you going to do a Snapchat rendition of Wolverine mascot?
No, I've never thought of that. Though I wanted to ask, Jens, the project that you put together to advertise where you drew my face and my facial, I'd love a copy of that, please. That was so cool.
I've shown it at the beginning of this. I'll send you the program. It's called Sketch Guzdial.
I love it. I love it. Thank you.
Just a thought.
Did you get feedback from the students? I hope they liked it, but
the feedback was really quite stunningly great. I still haven't, as I mentioned, I have a PhD student, Tamara Nelson Fromm, who interviewed 5 of the students at 2 different points in the class, at about week 5 and about week 12. I've just started looking through the transcripts. The research question that she's interested in is, so why do students take a course like this from the liberal arts and sciences? And what are the challenges they face? I find that question to be really interesting as another way of thinking about what is computational thinking, right? When we think about computational thinking, we talk about abstraction and decomposition and things like that. But if you think about the most fundamental stuff are stuff that like a musician faces the first time they sit down to a programming language, but they don't ever want to become a software developer. One of the stories that she told me was that I actually have a bunch of artists in my class, students who want to be professional artists, who are taking this because they realize computing is a new medium for them, like oil painting or like pastels or like watercolors or like sculpture and clay. And they want to become proficient in this new medium. So these are not people who ever want to learn about, GitHub or how to do abstract data types. They just want to be able to express themselves with this new medium. And so this is the sort of thing that we're finding out. The student evaluations were terrific. I suppose a better indicator of how successful the class is that we have more than doubled the number of students in the 2 classes. And the creative expression class, I had 9 students last semester. I have 35 this semester. It has more than tripled in size. Wow. Yeah, so yeah, I think that's a very positive sign that it's going well.
So we're talking about humanities, Mark. Here in this session right now, I think I really don't know much about you participants, but I think a lot of you are from business, so which is arguably also a humanity, right? And I think it might be one where we think that business people know about computing, because who would be in business and say like computing isn't my thing? But it might be interesting to liken it to humanities, right?
Yeah, I mean, certainly the issues of ethics play a big role. At the end of the class, I was able to get into topics that particularly the business students were really interested in, like cryptocurrencies and NFTs, because the very end of the course, we entitled it Limitations of Technology. I mean, how does cybersecurity really work? How do you get the S in HTTPS? It works because we don't know how to factor large multi-digit numbers, right? And if we did know how to factor it, the whole security would break down. And that's why quantum computing might break everything. And then the NFTs were particularly interesting to talk about because we did have artists in the room. And for artists, NFTs are a good thing because it allows them to sell their digital art. But on the other hand, it's like, but is it actually have any value later? How does that? So we were able to have those conversations. So that was all really great. Yeah, so yes, Liz. So NFTs is something that my artist students are definitely thinking a lot about. And so that was valuable.
So I'm interested in in maybe somebody of the participants. Are you doing computing with your students in class? Like, what are the kind of things you're interested in when it's about computing? Is it more like learning to use a particular application, or are you more like into teaching certain parts of maybe data science, R or Python? Uh, any of these questions come up with you?
Yeah, hi. This is Colin from San Jose State. So I teach in the AIS department, but anyway, my PhD is in management of information systems. So I teach a bunch of data courses where I teach both a little bit of SQL. I taught a little bit of R, but mostly primarily we teach students how to use different tools like data science tools, all these kind of things. And yeah, I plug in, especially at the master's level, I plug in some of these no code, low code kind of systems because they're pretty easy to use and they like it. I don't really have engineering students and I don't really have computer science students, but most of the students in business, they kind of like to be able to do these things. Something like Snap or something like, I know, Alteryx or something, things like that, they really, really enjoy. So I guess both using the tool and really understanding some ways to customize the tool, but not going into too much depth related to the computer sciences and even some of the theory behind it. I'm not sure that they actually know it, but most of the times they seem to be able to kind of grasp all the concepts.
I'm going to share my screen a little bit to show you that what I've been able to find is the custom blocks in Snap make it really easy for me to essentially create a no code, low code kind of tool, but within Snap. What you see here is this is some of the database things that I'm doing. So I can show the items from billionaires where column A equals Bill Gates. And this is essentially it looks a lot like an SQL query. And so I can recognize, I can reference the sorts of things that they've done before. This is an example that I totally stole from Yad Ganyen's, where we've got this the collection of passengers from the Titanic, and we're going to show the items from the Titanic where the gender is male, and then grab just we're going to split the names into 3 columns and then group by the first names. and then sort. And now you get the most common first name on the Titanic is William. The second was John. The third was George. And actually being able to do this is really hard in SQL because we're taking a field and splitting it into 3 fields. And so this was really neat. The other one I want to show you was the way that we've been doing web pages. So we actually have built a set of blocks. Let me get this out of the way because that one's covering up. I have to have JavaScript extensions turned on to do this. Move that away. Anyway, it's not working. So this one here is we are making a web page, making a paragraph, making paragraphs. And so when I click on this, it shows me the HTML, and then it really does open up, and the snap page is embedded inside of it. My students, even my computer science students, really love this. And you can see actually down here, we also created an extension to it so that we could do style sheets as well. So here's the exact same page, but with CSS applied to it. So we get a slightly different effect. We get some blue background, and we get the centering of it. These blocks are doing HTML, but nobody ever have to type any backslashes or angle brackets. And so the students can play with the ideas of HTML right away. We do this, you know, they're building web pages within 15 minutes in the class when I start talking about this stuff. But I'm not hiding the HTML. It's still showing up over here in the stage, but they just don't have to type it. So I'm able to get much deeper into HTML ideas and CSS ideas and how should you structure your page? Because now, you know, you want to see this page without style? Well, I'll just pull the style sheet back out and I can re-render the page, but without a style sheet. And being able to play that easily with how styles work and how the structuring works. You can tell I'm a big fan right now of Snap because I'm able to create a lot of no-code, low-code types of experiences by simply building a bunch of custom blocks.
Oh, that is really beautiful, Mark. I wasn't even aware of that. That's amazing.
The real trick was building the block that would render the HTML.
Exactly. Yeah, because how are you even going to get there? Oh, you're going to have to teach me this. Yeah. How can you
This is
escape?
actually awesome because we do have an HTML class for colleagues' kids, and
Yeah.
they type a lot, and it's not very fun for them. So maybe we might want to check this out.
Do you
Great.
need a server for that?
I am using a server. I have
See?
built a very, very small server script that accepts using URI encoding. I accept the HTML in the URL and I simply put it and serve it back again.
Because that's kind of the only thing I could think of how you could manage to pull this off. Cool. This is awesome. Love it.
So it's a little bit of a trick. So that was a very long answer to the question about how do you do this with like low code and no code. So I apologize for that. But because I think about the similar things. My students are not really keen on doing software development. They certainly don't. They're not really keen even on learning things like Python. But I'm able to touch on a lot of different concepts pretty quickly by giving them custom blocks that scaffold their way into these concepts. Really excited about it. And actually, at the end, when I introduced both the HTML and CSS, a lot of my artists were like, "This is so great. Can I make my whole website like this?" And it's like, no, this is just a teeny tiny thing. But what a great motivation. Now go learn some other things. Now go beyond this. My job is to make you feel confident, to teach you the basic concepts, and then you go play. Go on.
Mark, thank you so much. This has been such a privilege to have you in here. I hope you all appreciate this. Like, you got some world-class guest appearance here from our friend Mark Guzdial. This is awesome. Thank you so much to share your experiences, not just with Snap, but with the very thing we're working on at this bootcamp today. This is such a great fit. This is awesome. I made a recording of this. We're gonna ask you whether we can share it with the community afterwards. Thank you very much.
Take care, everybody.
Thank you, Mark.
Thanks, Mark.
So now comes a time of intense working on our projects. So where we're going to turn this little drawing program, the single gesture drawing program, gradually into something that will get to be intelligent. And we're going to do that in several steps. First of all, before we dive in, we'd like to really make sure that all of you have got the sketching and drawing program in a working state, because we're going to build on that. We can help you out if you don't. Then we can share a working version. But otherwise, you know, if you feel like there's something that it doesn't yet do what ours did, please speak up so we can look at it before we start with the next step.
Or you can keep programming from my project that I now posted to the chat again, and this has the current status that we had before lunch.
If you open Yadga's project, you can save it. You will not override Yadga's project. So for everybody, he uses it. So this is also a great way. If you do this with your students, you can share a stub project, you know, and then get everybody up to speed on the same thing again. So even though this is shared in the cloud, and even though you can save your project to the cloud, it's not collaborative in a way that somebody else can override your project. They will override it to their computers and to their accounts.
Okay, so the next step that we want to do is animate the gestures that we've drawn. But before I start showing that, I wanted to explain a few things that came up during the first session, or the first part of the session in the chat, and also because somebody just asked about costumes. So the first thing was somebody asked whether they could share a project or the project that we're currently doing on their website. Yes, you can do that, but you need to store it. Also, you can embed it in an iframe, but you need to store it to our cloud. So this is how the My Project section looks when you're logged in. So those are all my projects. And each of the projects has a separate window where you can look at the project. And there you can get an embed button, and this is the code that you can copy to your website to embed the project in an iframe. Keep in mind, though, that people can only see your project if you published it or shared it from the cloud. So there's several statuses that projects can have. So they can either be private, that means that only you can open the project from your cloud, or they can be shared. So that's that one. Shared means that I have a unique link, and if I send that to you, you can open the project, but nobody else can find it on the website. So it's basically like the unlisted thing on YouTube. And then the final, or the largest thing is a published project. Published means that everybody can find the project on the Snap site. So this means that when you go to the Snap front page and you browse through latest projects, your project might be there. And also if people search for the project, so what was its name? Alonso of, maybe I hope I find it. We'll see. Search for it, please. Anyway, I can find projects. Yeah, there it is. So you can also search it and find it then on the page. So that's the published status. But if you share your project or publish it, you can embed it with an iframe into your website. The second thing that I wanted to explain again is when you have to, or not when you have to, but you can always see that your project has unsaved changes. And this might be something that you've drawn on the stage, or a comment you've added, or a block that you changed, or a sprite that you added. So whenever you have something changed in your project, this small pencil icon will appear in front of the name of the project. And this means that you have unsaved changes. So when I save my project now, you see that this will go away. So now everything is saved in this current status. And the third thing that Jens just asked me to show, because somebody asked during break, is whether and how you can import media into Snap, like images. And there's several ways to make your, let me show my sprite real quick again, to make your sprite look differently than it does now. Jens showed real quick that you can draw things here with the paint editor, but there's also this import costume from your webcam thing icon, and this, you need to enable this when you use it for the first time. So you need to allow your browser to access, or you need to allow Snap to access the webcam. But once you allow that, you can take pictures from you with the webcam, and your sprite will be wearing that costume. So this is still the same object, it just looks differently. And also you can just import media from your computer. So for example, I have this photograph that I really like. It's of me and Alonso, and I can also just drag that in, and I can also use media that I downloaded on my computer in my project. So if you want to work with photographs, this is how you can do it. And by the way, this also works for sounds. So you can either record your own sounds, or you can import them, or we also do have a small, not particularly good library available where you can, for example, load specific images that you can use in your project. So for example, this is Alonso, Snap's mascot. I could also use that from the library. Okay, so back to the project. Great. Okay, so back to the Grand Gestures project. In your gesture recognition journey, we next want to create animations. And for that, we want to use the first custom block that we provided for this learning resource. And you can find custom blocks at the bottom of the category where they belong to. So the animate block is in the looks category, which means it's at the bottom of the purple looks category. And you can just drag that one out. And as you can see, it's also a C-shaped block, so we can put other blocks in there, other commands in there, and they will be executed. And you can also inspect what the block does and how it's made by right-clicking on it. You don't have to do that. I'll show it to you by right-clicking it and then clicking on Edit, and this will open the block editor with the block definition. So whenever you wonder what a custom block does, you can just look at it yourself. And this one, for example, whenever I draw something, it'll move the sprite to the center and makes it face in the direction 90, which is pointing right. Then it's setting the size to the 100% that it has. And then that's the interesting part. It switches the sprite's costume, so the way the sprite looks, to the pen trails. And pen trails is an interesting feature. You can find the pen trails block in the pen category, and it's a reporter. And what it does is it reports, or it returns, everything that's currently drawn on the stage. So that's my sketch. And I can switch to that sketch. So I'm wearing the costume now, and then I'm showing the sprite, and then I'm running whatever action is in here. And after I'm done with that, I'll just go back to the center, point in the same direction that I did at the beginning. I'm setting the size to the original size that I had in the beginning, and I'm stamping the drawing again, which means after I'm done animating my drawing, I'll just put the drawing back on the stage, and everything is as it was when I started. So let me show you what that means. I have my drawing here, and now I could, for example, say I want to make a heartbeat, because that's the example that we already had. So we're slowly increasing the size, and then we're decreasing it again in one. That we need for that is first the animate block, and then we need from the looks category the change size by and the set size to block. And from the control category, we need 2 of the repeat blocks, because we want to make our heart like bump twice, because that's how the usual heartbeat works. We want to increase the size slowly, which means we just repeat 10 times, change the size by 10. If I animate that, it'll actually also already set the size back to 100, because that's what it does. But since we want to throb twice, we need to do that by ourselves. So the script that's executed once is repeat 10 times, change size by 10. So its size is 200 then. And then we're setting the size to 100 again, and we're doing the whole thing twice. And we put all that into the animate block. So let me draw a new heart. And let me click on that. And you see that whenever I click on that, it'll bump twice. What you can also see when you do it on your own screen is that the image resolution gets way worse than when you started. That's because whenever we stamp the thing again, we kind of lose the resolution, the original resolution. So the quality of the drawing gets worse, but in the end, we only want to animate it once, so we'll be perfectly fine. So this is the animation that I now want all of you to build. The first one is going to be for a heartbeat. And again, you need the animate block, you need 2 of the repeat blocks, and you need the change size by and the set size to block. And then when you're finished with your script, also please try it. So draw something. By the way, this of course also does not only work for a heart, it works for everything. So I would also draw a star and click on it, and it would also make that bump twice. So yeah, up twice. Yeah. Okay. And maybe you can indicate in the chat when you're done with the heartbeat, because then I have 2 more animations that I want to show you. And then you can have a little time to build one more yourself. And maybe one more thing, we didn't attach a hat block here. So for the script to run, you need to click on it. It doesn't run automatically. If you don't add a hat block, you need to click on scripts to execute them. So the second thing that we thought about is maybe something for a star. So we wanted to twinkle, which means we wanted to hide and show and hide and show and hide and show. And we kind of want to do that in a rapid succession. So let me draw a star first to do that. And then let's grab another animate block. And we need the hide and show blocks. And we need a repeat because we want to do that several times. So let's do it 10 times. So I want to hide the star and I want to show it. If you do it like that, you can't see it on my screen anyway because it's not transmitting the images or the video fast enough, but you can't see anything because you're just hiding and showing super fast. Our computers are super fast, so we can't see what's happening. So what we need to do to avoid that is we need to add a little delay. And in the control category, you can find a block that says wait seconds, and you can specify a time in there. So let's maybe do 0.2 seconds, and you can put that block in here. So once between the hide and show, and also once after the show. And now when you run that on your computer, you should see that the star kind of flickers and alternates between hiding and showing the sprite. And by the way, you can also comment or annotate your code, which kind of makes sense when you have scripts that look pretty similar and you want to use them later on, or you want to show other people what they do. You can right click and select add a comment, and this will attach a comment box to your mouse pointer, and you can either just drop it somewhere and then it will stay there, or you can also connect it with a script, and then when you move the script around, the comment will move along. So for example, I could write in here, this is an animation or a heart, and here I could add one that says this is an animation star. And you can also kind of hide these if they annoy you because they take up so much space. And then you can show it again when you click on that arrowhead. Okay, so the last animation that I wanted to show you is, you can also do a propeller, but I wanted to do a boat, is something where we turn our object a little bit. So in this case, for example, we want to slightly turn right, then we want to turn left, and then we want to turn right again. So we get like this boat on a sea animation. To change the direction that your sprite is facing at, you can go to the motion category, and there's either blocks that directly point into some direction, or there's blocks that let you turn your sprite. And in this case, I want the turn right block and I want to turn left block. Those basically do the same. If you input negative numbers in the input of the turn right block, this also will turn left. So you can also just use that one if you want. And then we need another repeat. And then we need another one of these animate blocks. And in this case, again, as I said, what we want to do is we want to slowly turn right. So for example, we could 10 times turn 10 degrees right. If I do that, this is what it would look like. That's maybe a bit too much. Maybe let's do 10 times 5 degrees. And then we want to turn the same amount back and the same amount to the left. So we want to repeat 20 times. Wait, I didn't explain duplicate. Let me just grab another repeat block. We want to 20 times turn left 5 degrees. So this is what this would look like. And then we want to turn back to the middle again, because right now we're facing left. So let's grab another one of these repeat blocks, and then let's turn right again by 5 degrees. So, okay, this is still a bit too much. Maybe I'll just do 2 everywhere. And this is the cool thing about Snap. You can just try these things out. Nothing breaks. If you don't like it, change something. So this is kind of right. So whenever I animate my boat, it'll slightly turn left and right. If we wanted, we could also change its position while we do that. So for example, we could, while we turn right, we could make it move up a little bit, let's say by 1. And whenever we turn left, we make it move down again. I never tried that. I have literally no idea what will happen now.
It's going to look fine.
And then we'll make it move up again. Maybe even more. So let's also do 2, -2, 2 here. Yeah, I kind of like that. Okay, so this is how my boat's animated. Jip to jip. Let's try it once more. Whenever I animate my boat, I'm slightly turning right and changing the Y position by a positive value. So I'm turning right, moving a bit up. Then I'm turning left, moving a bit down. And then to get back to the original position, I'm slowly turning right and moving up again. So this is how I animate my boat. Okay, so these are the 3 animations that I wanted to show you. Okay. You will get more time later to work on your animations. So maybe let's go on to the next step that we need for gesture recognition, which is actually the storing of paths that we then can use to compare different sketches with each other. And Jens will show you how to do that. Please all make sure that you save your current project.
And this, by the way, Sunny, I think, will answer your question. Do I have to redraw my shape every time, or can I replay the picture that I drew? This is precisely the great question. Wonderful, because it's the perfect segue to what we want to do now. So what you've now done is you've written a program that lets you sketch a single gesture drawing. We've shown you how you can make it. You can do more complicated drawings, but for the purpose of this AI, we want to have the single gesture thing that you can draw in one stroke. And Jadka has just shown you how you can turn what you drew into something that you can program, so that what you kind of drew on the stage will become an object that you can then use the animate block with to move it around, to do things, to make it grow, and things like that. Now, let me share my version. I've been following Yadga along. So here's my version of the project. Yadga, please, is this right? I think it's right. So I have 4 animations. This is my version of the rocking boat. Yadka can draw the boat better than I can. I also made a propeller. And when I draw a propeller, I want it to turn. I mean, yeah, that's kind of my funky thing that I did. And I stuck little comments here. Now, remember what we ultimately want to do, and Yadka pointed this out very subtly. We want the program itself to decide which ones of these it has to run, right? I mean, that's the point. We want to, when we draw a star, we want it to run this animation. And, and when we draw a heart, we want it to run this animation, but we want the program to find out which animation it has to run. And in order to do this, we need to be able to find out more about what we drew than just to use it as a picture. So in order to do this, we need to manage and kind of remember what we drew and store this somewhere where we can compute with it. Now, whenever we remember something or we want to store something, this in computer science terms really is a variable. So we want to make a variable. Now we can make a variable in the variables category of the blocks. There are several ways in Snap how you can make variables. Those of you who know more about programming and computing probably have heard about the word scope. We have various levels of scope in Snap. I'm going to show you, for the purpose of this program, we're going to work with global scope. We're going to start with global scope. We can make a variable, pretty much like you did in AppGyver. If you've been to that workshop, we make a variable and we can give it a name. And so I'm going to propose, we're going to call it sketch, the variable. And so we can decide whether the variable should be for all sprites or for this sprite only. Never mind about scopes. We're just going to make this global. We're going to make this for all sprites. If I click OK, 2 things will happen. Over here, I get a new block called sketch. It's a round block. We call it a reporter block. And on the stage, I am getting a little readout that shows me the value of the variable. Right now, the value is 0 because there's nothing in there. If I click on here, it's 0. And in this variable, I now want to store the gesture, the path that I drew, that I'm drawing with the mouse. Now, this is like when I'm drawing something, I'm moving the mouse cursor, and all the time, it's going to the mouse cursor. And so every time it is moving there, I want to record the coordinates where the mouse is. How do I do this? There is something in the motion category. Remember these puzzle piece blocks, they do something. There are statements. These round blocks, they are reporters. They are expression blocks. So here is the X position block. If I click on this, I see the X position of where I left the sprite here is 168. The Y position is 13. That's somewhere here. That's exactly the last point where I left off. Up on top, there is a position block. If I click on this, I'm going to put the X position and the Y position in a single readout. That's a list, right? I've shown you before. So it's a list of these 2 positions. So what I'd like to do is, here's my sketch block. I want to initialize the variable. And when I get the set block, the sketch block, I can set it to anything. I can set it to foo. Now when I click on this, see, now sketch is foo. When I set the variable to a list, and be sure to collapse the list, because then it is an empty list. When I set the variable to an empty list, now it's an empty list. You see, this is a list here. Now I can add things to the list. For example, I could add, a thing to my sketch. And now I'm seeing a field called thing in my sketch. I can add, for example, the Boolean value true to the sketch. And now my second item is true. See how this works? And if I want to reset the sketch, I just set it again to the empty list. I could also, add the position of where the mouse is right now. This is the position. If I add the position to there, I'm getting a list with a list. And that's kind of cool. So this is what I want to do. At every step here, when I'm going to the mouse pointer, I want to add the position where the mouse pointer is to the list. And before I do this, before I do any of this, I want to reset my sketch to a new list. So with these two things, we can now do this. Now if I draw a heart, oh, see, something else is happening. This turns into a table. A table really is a list of lists. So this now is a list of 168 X and Y coordinates. And if I draw, as long as I keep drawing, that list starts and keeps going, keeps growing. So this is how I can record my gestures. And now, why don't you all just do this part that records the coordinates in a path called sketch. So again, let me recapitulate. You go to variables, you click on make a variable. Up here, you give it a name. I'm giving it the name sketch. I leave this variable, the scope, the variable that it's global. It is for all sprites. Then you press OK, and when you press OK, you get this sketch block. You initialize the sketch variable to a new list. And at every iteration here, you add the current position to the sketch. Try that out. You can already see where this is going to, right? Now we've got a list of points that represent kind of the heart that I've drawn here, right? So, hey, see what I'm going to do is I'm going to take another one of these out. In fact, I'm just going to click on this. My heart is gone. It's no longer on here, but it's still in here. It's still inside the sketch variable. So here's my sketch variable. How could I replay this? What do you think? So for this, we have a bunch of loops. So in the control category, we have some loops, repeat, where we can say repeat until the condition is met, or repeat a finite number of times. We have a for loop. In the lists category, we also have a for each item block. This block iterates loops over all the items in this list. So this could be a great idea. So in fact, let me show the sprite again, and let me click on this. So this is my sprite now. So if I go for each item in Sketch, I could, for example, I could say, okay, say each item for a second, right? Now, if I click on this, it will say, yeah, each item for a second. In fact, I can make this a little faster. It'll be a little faster now. Now it says all the items. So we're getting each item. The value of each item is always the next one. These are two numbers. When we move the sprite, we can make it go to X and Y, right? So now if X and Y is both 0, it goes to the middle. If X is 20 and Y is 100, it should go a little bit to the right and a lot up. So yep, that's what it did. If I want to say, okay, go to X minus 50 and 100, now it should go to the left. So we can use these X and Y coordinates, but here we already have the item as a 2-item list. And this is something where we can also, instead of this, where we specify each coordinate separately, we could just use our go-to block, which is go to random position mouse pointer to the center, or any 2-item list. And now look what happens when I click on this now. It replays something. That's already a great beginning. And it kind of looks that it's replaying a heart. How could we make it draw the heart?
Pen down.
Pen down.
Right, exactly the same thing that we did over here, right? So we could, after we go to each item, put the pen down, and when we're done, we're lifting the pen up. Again, I'm putting it after the go-to block because otherwise, like when it's over here, it would already draw a line. Let's try this. Yay, wow, okay. Let me try another one. In fact, I'm putting the show up here so I can see. Well, actually, I don't need show. So now I could, for example, draw a star. I can see it's recording the star. I'm clearing it, and I'm saying this, and my star is again replayed. This looks kind of promising. I could now even go and say, I don't need to see these numbers. I trust they're here. I go back to the variables category, and here's a little checkbox that I can make it to turn it off and on. And I just don't need to see it. In fact, this now should work. Let me try to draw one of Yetka's cool boats. So here's my boat. Wait, how do you do this? Like this? No.
Actually,
Well,
I
whatever.
start at the top, but yeah,
Yeah, this
I'll
is
teach it to you.
my boat. Okay, so here's my boat. And if I clear this and I redraw it, it gets replayed. Okay, how about all of you try this now? With this little replay script. We don't need the show button. And try whether it works for you. You will find the for each block scrolling down in the variables. Underneath the variables blocks, there will be the data blocks, the list blocks, and there is a for each block. That's the C-shaped loop block here. See, the for each block has item. You can rename it. If you can drag it out here. This is a local block. It's a local variable. You can peel it off. If you
Okay.
want to delete it, you can just again drop it on there or delete it somewhere here, and you can peel off more, right? So this is also a variable. See, if you click on it, it will tell you that a variable of the name item doesn't exist in this context. It only exists inside this script,
Okay.
right? So this is a local variable, an example of a local variable.
Okay, thank you.
You can notice that it's kind of elevated, so that makes it turns it into a template. That's also an input slot. The input slots in Snap, there are several kinds of input slots, like ones you can type things in, and others that are a symbol. And this symbol here is the symbol of a list of data. So because it kind of looks like this. And you can hide and show kind of, the watcher, the monitor for the sketch using this little button. So you put this in here. Okay, So now we're collecting data. This is kind of getting more exciting because with data we can do stuff. And I'm going to hand it over to Yadga now. It's working for everybody, I hope, so we can continue. I'm going to stop sharing my screen.
I can also upload my version again just to make sure that everybody
Great,
can
good idea.
work with that. If something doesn't work, but it's the same link from before. So if you just if you still have it open and refresh it, you'll now have the current version of the project. Okay, so this is my project. I'm still showing the sketch variable. We are now recording paths, which is pretty cool. But to actually make them comparable, we need to do one thing. Why is that the case? Let me draw something new. So I'll draw a heart, another heart, and I draw it very slowly. Okay, you see this heart has 621 data points. Now let me draw another one. This heart only has 79 data points. So when I compare these two with each other, it'll never recognize that this is supposed to be the same gesture because it depends on how fast I draw things, how many data points I get. So what we need to do is we need to normalize a sketch, every sketch, to a specific number of points. So all the sketches in our examples list of sketches that we'll now create as well have the same amount of data points. We prepared a block. That does that for you. And you can also find it at the bottom of the looks category. It's called Resample. The Resample block is a custom block. And if you right click, edit it, you can see how it's done. I don't want to get into that too deep. It's also explained in the teaching materials in the blocks section for educators. But what it basically does is it measures the distance that's supposed to be between each data point when you only have 64 points on the complete paths, and then it distributes all these 64 points evenly among that path. And what it takes as an input is a list for the first input slot. So this list is probably my sketch because that's a list of data points. And in the second input slot, I'm entering how many points I want. For example, I could try 12. Then it would average or distribute my sketch among these 12 data points, or I could do 128, for example. Ooh, 128. Then I would get a list with 128 elements. To see the difference, we actually have prepared a block that does what we just did and a little more. It's called render, and you can find it in the pen category. And if you right click on that, you will recognize a lot of things. So for example, the for each, go to point, pen down, we just built that. The render block does one additional thing. After you went to a point, it increases the pen size, moves 0 steps, and then decreases the pen size again. What that does is it draws a small dot at that position. Besides that, it's exactly doing the same thing that we just did with our replay script. So when I render my resampled sketch, you will see that you get the same drawing, but at every data point of the 128 data points that I now have, I'm getting a small dot. When I do the same thing, let me hide the sketch. When I do the same thing with 15 data points, it looks still pretty okay, but you see that it's kind of getting edgy here. I can try the same thing with 8 data points. It still kind of looks like a heart. Let's try 6. Yeah, okay, that really doesn't work anymore. If we try it with another drawing, so for example, let's do the star. We can do the exact same thing. So a star is definitely not recognizable with 6 points. The heart was still kind of okay with 8. The star isn't. Maybe let's try 15. Yeah, 15 kind of works. Let's try 24. So you can always re-render your scripts with different numbers of points. Just play around with it a bit and see how many points you need for most of the drawings. And then I'll suggest that we do 64 because that's kind of a reasonable amount of points that we can handle pretty well, and that also works for most of the drawings that you'll do. So maybe 1 or 2 minutes to just play around with the resample block a bit, draw different sketches and check how they look with the different number of points. And you can check that by rendering them. And then in the second step, we want to create like a library of examples. So we'll create another list and add resampled examples to that. But first, I'll give you 1 or 2 minutes to play with the sketch resampling block a bit. And again, as I mentioned in the beginning, but you might not recall that, this is the most important of the normalizing functions that's in the original $1 gesture recognizer, but there were 3 other ones. So this one's taking care, and this is really, it's the most important one. Without that, it doesn't work at all. Without the other ones, it works pretty well, as you will see later. The other ones were rotate, scale, and translate, making sure that the drawings are at the same position with the same size facing in the same direction. But resample is by far the most important of the normalizing functions in the algorithm. Okay. As I said, what we also want to do in this step, before we start recognizing things, we need a database where we store examples that we can recognize, or that we can compare our current sketch with. So we now will create that database. We do that in a table. So we'll create another variable that we call examples maybe. And for each drawing that we make, we will add its path and a tag for it, like a label, to this examples list. So all for that, we create one variable with the make a variable button. It's going to be a global variable as well, and I'll call it examples. And again, we need to set examples to an empty list so we can add stuff to it. We need to initialize it as a list. But we only want to do that once now, because we then want to add examples to our list. And we can do that with the add block that we already used. So we want to add stuff to examples. But as I said, in this case, we don't want to add just one thing, but we want to add a list where the first element is our sketch. So that's the path that we drew. And the second one is a tag for that path, a label. So for example, I'm drawing a heart. I'll write heart in here. And I click, oh, wait, sorry, I forgot. That's the important part. We want to add the resample sketch. So we need to drag out another resample block. So we may want to make sure that all the paths in our examples list only have 64 points. So that's how the script is supposed to look like. I want to add a list where the first element is the resampled sketch and the second element is the tag for that sketch to the examples list. So right now I drew a heart. If I click on that, I'm adding the heart, and you see that in my examples list, I now have that first element being the path and the second element being the tag for that path. I can add another thing. The star now. And I'm adding the star label here and click on that. Now I got a second element where the first element is the path and the second element is the tag, which is star. By the way, you can also show that as a table, and I find that kind of easier to read. You can do that by, how do you do that? All right, you click in here. You can click into the list and then select table view. So this will change the appearance of that listy thing to a table where the first element is a path and the second element is the tag. Again, to get there, I clicked into the inside of that list and then selected table view. Okay, and then we can add a few more things. It makes sense to add the the sketches that you have animations for. And also it makes sense sometimes to have several examples for the same sketch. So I also had a boat. So let me add the boat. This is my boat. Loop. And let me add I also added the propeller. Let me add that. Okay, so this is my Jeep. Okay, so those are my 4 examples. If you want to add more animations later or want to try out different things, you can also add them right now. So for example, since I just practiced that. What's the English word for that? Clef? Is that correct?
I think it's correct. Yes.
Okay. Bloop. So I can add several things. Also, if you have a wrong one that you want to delete, there's several blocks in here that help you with that. So for example, I forgot that I didn't draw a boat when I added the boat. I can delete item 3 of no, sorry, not the sketch, of my examples list. And now when you check the list, if I click on that, the boat is gone. And then I could draw a new boat and add that again. So if you did something wrong, no worries. There's blocks that help you change the list. Okay, so your job now is to create the list with the examples and add several resampled sketches for examples that you also that you already created animations to, or that you might want to create animations to later, and you want to add these to your examples list. And then we're finally starting with the recognizing process. Okay, so look, this is what yours might look like. And now you can click on that inner part of the variable. Mm-hmm. Right click anywhere in there. And click on table view. Table view. And this will change it to that view. If you want to change it back again, you can right click somewhere again and select list view. So you can switch between these. Oh, wow. No, I didn't want to do that. Well. So that was what I wanted to show you. And I think I would now hand over to Jens, who will explain the recognize block to you, because we already provided that for you in the sensing category. Usually when we do that with kids or with students, we ask them to build the recognize block themselves, because it's not super hard to do. But since we wanted to spend a little more time with the creative part, and since you didn't know Snap before, we thought we'll just give it to you. But Jens will now explain to you how it works and how we can use it.
Okay, so now we've already done, wait, let me get this. This is the state of my project, which I guess should be roughly where you're at. I made the examples database, the table, with one example of a path for every of the animations that I've made. So now you might have seen these diagrams where people make wild plans, and then there's this thing where it says on the blackboard, there will be magic. We're at the magic part now. Now we've collected data. We've made it so that everything we have in here is always 64 points long. We have made it so that whenever we draw something, we can also look at it in 64 points. So now we can compare things. In fact, let me draw something now. Let me draw a heart. Here's a heart I've drawn. Actually, let me not show this. Let me draw my heart. Here is a heart. And remember, I've got this sketch, and I can resample my sketch to 64 points. And this is now a list. And now I have a list of numbers, and I want to find out which ones of my examples comes closest to that number. to this path. So here, inside here, I have another list, and I want to know whether these points somehow resemble these points, or whether they're closer to those points. And how can I do that? In the materials that we've linked to, we've got some sketches that actually kind of show how this works. And the way how this algorithm does this is that we could, for every point here, for every point that we go to, we could find out the distance to a point in the path. And this is what we're doing here. We have a difference block that we're giving you. There's a difference block here. The difference block really goes, for kind of really does the distance between each corresponding point, like the first point here to the first point here, second point here to the second point here, and just accumulates all the distances. So I have a difference between one shape and another shape. So the current shape that I've drawn is in Sketch. I can resample it. Now I want to know what is the difference between this shape and the first one in my examples. You don't need to be following me. I'm just showing you this because we're giving you the block. I'm just showing you how this block works that we're giving you. So now I'm taking the item 1 of the examples. Item 1 of the examples is my pair. This is the pair with the list of coordinates and with the tag called heart. If I get the first item of this block is just the path. Now this is just the path. So I want to get the difference between the shape that I've drawn and the path. That is the accumulated distance between the points. That's 2,000 pixels. That might seem like a lot. 2,000 pixels is the accumulated distance between what I've drawn to my heart example. Let's check it against the second one, the star example. That would be item 1 of item 2 of the examples. Oh, look at that. That's almost 6,000 pixels. So the heart shape is way closer to what I've drawn than the star shape. Let's try with the boat shape. The boat shape is number 3. The distance is 8,000 points. Wow, it's even farther away from that. And let's try the propeller. That's 11,000 points. So with these examples, we'd say what I've just drawn here, the one that comes closest to it is the heart shape. And that's what we call the nearest neighbor of our given examples. Let me draw another one. Let me actually now try the same thing with a star.
Does orientation of the drawing matter?
In this case, yes, it does, because we're only checking the accumulated distance between absolute points here. In the original paper, the $1 gesture recognizer paper, they're taking the normalizing step some steps further. They're not just resampling it to the same size, they're also scaling it to the same bounding box. They're orienting it to the same, what they call intrinsic direction. And they're translating it so the centroid is always kind of the same thing. And then it's really very flexible. Then you can kind of draw it upside down, right? Mm-hmm. So with the thing that I've drawn here, I can check again. This is a star. Let's try it against the heart shape. The distance is like almost 7,000. Okay, with the second one, it's 1,800. That seems pretty close. With the third one, it's 5,2. And with the fourth one, so with this one, we'd say, oh, it comes closest to the star, right? And this is exactly how the recognize block works. We're giving you the recognized block. The recognized block checks the resampled sketch against, Somebody asked for undo. There should be undo. Oh, there isn't. Doesn't work. The recognize blocks against the examples. So let me see whether it works. Right, just delete this. So if I'm recognizing the sketch and examples, what I'm getting is the name star. And so I'm editing this block to show you this is really a simple block. We're setting a minimum distance to, infinite. And then we're cycling through each example in these patterns that I'm putting in here, calling these patterns. We're measuring the difference, as I've just done, of each path. And if the difference is less than our current minimum, for the first one it always is, we're saying, oh, we've got a potential match. The match is the example. And we're keeping track of the minimum. And when we've gone through all of them, we're taking the one with the minimal distance, and we're just giving back the item 2, which is the name. So for this one here, we're saying it's a star. For this one here, we would recognize a heart. For this one here, we would recognize a propeller. That's pretty amazing, isn't it? Because you got to realize that even if I draw the heart differently, like even if I draw it kind of up here like this, there's a pretty good chance it's still closer to my original shape than if I draw something like a propeller. It's still closer regardless where I draw it. And that's how the recognize block works. A custom block, right click on it and say edit.
Okay.
I'm drawing a heart here like this. And this might be strange, and it recognizes as a heart. Some of you might be drawing the heart completely different, not starting at the bottom, but starting here. Some of you might be drawing the almost same thing like this, right? It looks exactly like the heart I drew, but let me see what it recognizes. It's recognizing as a star, even though it looks exactly the same, because the path keeps track of the order of points in which I draw them. It has a sense of direction. So this is clearly also a heart. If I wanted to also recognize it, if I draw it differently, how about I add another example? So now I'm adding another example of a heart to my list of examples. So now I have 2 entries with 2 parts that are a heart. Let me see whether it now finds it. Now I'm drawing it the way I used to draw it. And it's a heart. And if I draw it like this, it also recognizes it as a heart. And that's another interesting part. So for this algorithm, we don't need very many examples for it to be pretty great, because this is what they call supervised learning. We're telling it, yes, this is a heart. But also, there's kind of this Led Zeppelin thing, Stairway to Heaven, that sometimes words have 2 meanings. Sometimes 2 words have the same meaning. And this is what we're doing here. We're adding synonyms, synonymic, like 2 paths that should have the same meaning. And that's interesting, because the more examples that you actually draw in different ways you add, the more you'll increase the likelihood that the program recognizes what you actually mean. The part that's interesting here that really is intelligent is that, what we're drawing here will look slightly different every time we draw it. But with this thing, we're still able to kind of guess what it's similar. So there are these 2 big ideas, is that we have a dictionary here, but a dictionary usually looks something up by checking its equality. Here we're not looking for equality, we're looking for similarity. And this is what this nearest neighbor algorithm gives us. I'm now handing back over to Yadka for the kind of final clue.
Final thing, yeah. Okay, cool. There was one question in the chat, and I don't know whether you managed to do that. How you can replay the examples from your examples list, and that's actually pretty easy and kind of works similarly to what Jens just shown. You just access the path of that element that you want to look at. So let's say I want to replay my clef. That's the fifth row in here. So I want to check the first item, the path of the fifth item, the clef of my examples list, and then I can just render that. So that would give me a replay of any drawing list. So if I wanted to show the heart, which is the first one, I would just change that number to 1, and I would get the, wow, this is really good. I would get the heart. So that's how you could replay any of the drawings from your examples list. But what we actually wanted to do, let me just add that here, and then I can comment that later for you. What I actually wanted to show you is how we now can connect these two things. So what we get here is, let me draw something, is a word. We already used words once or twice, but what I want to refer to is we used words here. So we can just use that word that we get here as an input to a broadcast block that we can then distribute throughout our whole system with them as a message with the broadcast block. So what we can do is we can just grab one of these broadcast blocks and drag all of this recognized thing in there, and I can now broadcast whatever I'm recognizing. And now I can react to that with my different scripts. So I recall this is the animation for a heart. So whenever I receive, and now I need to add a new message, heart, and make sure that you write it the same way you wrote it in your examples list, because it's only recognizing it if it's the same word. I want to trigger that one. So let me draw a heart. Let me check whether it's recognized. It was, because it triggered that script. Okay, so the next one, that was supposed to be a star. So I'm adding a new message, star, and whenever I'm drawing a star and it's recognized, oh wow, I want to trigger that script. Great, worked. Okay, this was the boat, I guess. Whenever I receive the message boat, this is supposed to happen. Hey. Okay, and the last one was the propeller. So whenever I receive the message propeller, I'm triggering that one. So I forgot how I drew the propeller actually. Maybe that way. Nah, no. Okay, I forgot. We'll find out.
Just add it as an example.
I can, yeah, right. That's clever. I can just add that.
Like
as
right now. If it doesn't work, add it as another example.
How did I do it?
Well, you can
okay, let's try it.
Yeah.
Yay! Woohoo! Okay, perfect. Okay. And now we can, of course, also just trigger that reaction automatically without me clicking on it. We'll just add that broadcast block at the bottom of our drawings or sketching script. So whenever we're done sketching, we'll just broadcast what we recognize. So let me draw something. Whoop, automatically triggering heartbeat. Let me draw a star. Yeah, it's flickering. Let me draw the boat again. Ooh. Now that happened. Now it happened. What somebody else said before. Don't start drawing when you're not done yet with the other thing. So that was the boat, and I also have the propeller. I hope. Yay! It recognized all of them. So that's it, and you can now use that to create stories. And that's the part where we want students to spend a lot of time with. We don't have that much time left, so I guess we only spend a little amount of time with that. But we want students to come up with their own interactive stories that they then tell in class and present to their to the audience. And they can either come up with like their own stories, or what we also suggest is just take something, a fairy tale, split it up into several parts, a children's book, give everybody a page of the children's book, and tell a group to animate that part and then tell a story together in class. And the cool thing is, because everybody's drawing different things and everybody will come up with different animations, this will hopefully most likely be very different animations and very different stories. And if you give kids a lot of time, or students a lot of time, there's also many more things that you can explore. Like you can make more complicated animations than the ones we have. You can, for example, also combine it with sounds or with other things that you've drawn. So for example, when you recognize something specific, you could just switch to another costume and show that. So all of these, you can trigger reactions in the background by broadcasting something when you recognize a thing. So that's basically unlimited possibilities on what you could animate. So you all please now add the broadcast block with the recognize block to your sketching area or the sketching script, and then add a corresponding when I receive head block to each animation script, and make sure that the message that you want to receive is the same message that you also go into broadcast when you recognize the thing. And you can add new messages by clicking on the drop-down menu and select new. This will open that message window and you can type the name of the message in there. Okay.
We really love this wave machine learning. It's an algorithm that is very explainable. We can reason about it. There is nothing magic going on. It appears to be magic, but it's very explainable, and we can program it all from the ground up, right? And it's even kind of something that we can see how it learned because we're assisting it. We're supervising the kinds of examples that we're teaching the AI. And the magical part about it is that, you know, we think we're drawing the same thing, but we're never drawing the exact same thing, and still it is able to recognize it. And so there is some automatic abstraction in there, and that part makes it appear to be intelligent. Maybe, Jaka, you'd like to talk about diversity and about bias?
Yeah, right.
Quickly, just very quickly, because Mark touched on that subject.
Yeah, right. So this is, as I think I referred to that in the beginning already a little bit. This is, and Jens also did, this is a project that where you can show bias and like discriminating against people pretty well, because as I mentioned, left-handed and right-handed people draw differently. And if you train it with your gestures, it might not work for other people. And if that's your own system, that's fine. But if you want other people to use it, that's really problematic. So we want then in the teaching resources, we ask students to try other person's projects and see whether they work. Yes. And we specifically and then ask them to come up with solutions. And one of the solutions, of course, is to add more examples from a diverse group of people. So also motorically impaired people, also left-handed and right-handed people, maybe also people that draw very well and people that don't draw very well. So a more diverse list of examples will help your program to be better usable for everyone. And then, of course, also we want to get to these other normalizing functions that might help make the program more flexible. And then finally, we again revisit what we did at the beginning, our expectations to gesture recognition, where we could use it in where we do use it in our everyday life, where we could use it additionally, and whether we think it's a good idea. So the students are then supposed to discuss.
Well,
So what I just said is we want students to discuss where they think advantages and disadvantages are, and we hope that they will come to kind of similar conclusions that they already did at the beginning. It's a system which is kind of easy to get into because you don't have to know how to read. It works across different devices, across different platforms, but it discriminates against motorically impaired people that weren't part of the training process. And it's maybe, although it works across devices, it's not the like most, how do you say that, clear system maybe. So it's a bit squishy whether I draw a propeller or a flower or something like that. So things are, it's not the like best system to distinguish all things. So text might be better for that, for example. And that's then the final conclusion of the module. So after everybody showed their projects, we're doing the reflection, talk about bias, talk about how we could improve things. And then we hope everybody had a good experience learning artificial intelligence. And again, going through the whole process of implementing the AI, training it, refining it, and applying it.
Question from Liz.
Okay.
Exercises do we have available to give to students?
Sorry, can you say it again, please?
About the documentation or exercises we have available to give to students.
Yeah. So in this particular learning resource, where there was that one, we have seven worksheets available that I show real quick at the beginning, but let me just go through them again. So the first
those
one
are
is
meant
an intro.
For students, actually.
Those are meant for students. This is a like a class discussion, and then everybody writes down like a few points of how they meet gesture, or where they meet gesture recognition in their life, and why they think it might be a good or not so good idea to do it. This is the resource for the sketching program that we did. So this asks students to build the sketching program by themselves, but if they don't manage to right away, we do have tips for helping them, and if they really don't manage, we'll just tell them how to build it, and then how to test it. The next step is animating. Here we also do provide 3 examples that people can just try out. So this, for example, is good for a propeller, because this will just turn the sprite 360 degrees in total. I have literally no idea what I wanted that one to be. Move and turn. Okay, it moves and it turns in a square, a 50 pixel long square. And this one changes the size and increases the size and then decreases the size again. So kids can try these out, and then we ask them to come up with a few examples. This is what the sketch should look like, and this is the animation idea. And then they can also check back with teacher or educator whether that's a good idea, and whether they can actually realize that, because they have the means the knowledge and snap to do that. And then we will, as we did, create the path and replay the path. So this is a bit of info about paths. We'll tell them how to record a path. We'll tell them how to replay a path. So that's everything we did today. Then we have a bit of information about how we want to compare these paths. This is what Jens just showed you, with the distances between, the differences between 2 paths, and then why we need a resample. We explain the resample block. We ask kids or students to draw one of the sketches, and then the same sketch with just 10 points, and then with the least number of points where it was recognizable, and that might be higher or lower than 10. And then we let them build the or we let them add examples, and we let them build the recognized block. And we ask them, as I said, to build the recognized block themselves. If you think that's too hard for your class, you can also just provide it like we did for you today. That's no problem. And in the final step, we do what we just did and add the head blocks. So we tell them to broadcast the message of the label of the gesture that they recognized, and then how to react to that gesture. And the final project, as I said, is illustrating a short story. And we want them to tell the story and draw the gestures along and animate the story. And then also it depends on the educator teacher whether they want the class to do one story together or whether they want every project group to do a separate one. Also, we suggest to do that as a like a partner project with 2 people together. And finally, we're doing the reflections. As I just said, this is which edge cases can't your program recognize, to find out that we probably want to have more examples and that we might need other normalizing functions, and then whether they wanted or didn't want to use more gesture recognition, whether they think that makes sense. So that's the material for students, and everything else is made for the educators.
Thank you, Yetka. So you've got all the materials, and for those of you who'd like to take it further, maybe you can remember some of the things that Mark Guzdial kind of told us. I really liked his examples of, remember the homework he gave to his students, like come up with another exercise with another gesture, but I have to be able to draw it, which is kind of exactly kind of the idea, like, oh, but you wouldn't, would you draw it like this? Would you draw it like that?
Why would you?
Yeah, well, so there's lots of things to be able to reflect on things. I just like to show you one more thing, how we can do the complete $1 gesture recognizer. And I'm going to, wait, is this the link? Nope, that's not the one. That's the one I already, let me share the link with you and show it to you. This is another link with a full gesture recognizer, because there was the question. I'm going to share my screen again. The question, like, does orientation matter? So this is another version that has the exact same blocks, but it has the full version. So here's something you will find, a normalized block in here, where it's the same thing. We're drawing a sketch, and we're setting a shape to a normalized version. This is where in our version we have the resample block. Here is a normalized block. Normalization is a little more. So we're also resampling, then we're rotating to an indicative angle. We're scaling it to, you know, a fixed size, and we're making sure it's always in the center. And so with this, you know, we're again starting out with nothing and with shapes. So this is something where we can just train something, where we could say, you know, okay, again, this is our heart. The first thing, it doesn't have any match because it has nothing here. So now I could say, okay, this is an example of a heart. And again, you can see now I have a heart here. And now everything, since it's the first thing, everything I'm going to draw next is going to be an example of a heart. So of course, this is going to be a heart, as is this is going to be a heart, as this is going to, like, it only knows a heart. Of course, everything is a heart. But now I can say, okay, no, this is an example of a clef. But I could say, okay, so this is an example of a heart. No, this is an error. But if I draw the arrow like this, oh, it's fine. It actually says it's an error, but so it can already distinguish between orientations and whether I draw the heart like here is still it's still hard, right? And the error is still something when it points in a different side. So this is the project we're just sharing with you that takes the idea of abstraction, of normalization further. Feel free to reuse anything you like. Feel free to look at the code. For example, see we have a list of blocks. Scaling it is really trivial when we have data. And when we scale it, it's easier to like when we're making sure it's always kind of at the same size. It's way easier to compare those, and we're going to have a greater variety to find. And this opens up ideas that you can use yourself or tell your students. Like here now, this would be something where I'm training a bunch of gestures. So we call these examples in our project that we made together. Remember, you can export any list of examples. The list of examples really is what they call a model. It's just data. It's data that you've trained. You've made the examples, you've tagged the examples, given them a name. You can export this as a CSV file. You can import this into another project that just uses Recognize to animate the things that are in there. So I can share my set of tags and of examples, my model, with your program, and you can animate it. And this way you can let kids, delegate parts of the job of telling a story. There might be some who want to design the shapes. There might be others who want to train the shapes, and there might be yet others who are good at animating the shapes. So these are examples that you can do. And last but not least, hey, Yatka and I are using this for our own talks, to animate our own talks, because it's fun to have something where something springs to life magically as we draw things. Oh, and there's also, Yatka, why didn't you show the courses?
Yeah.
Like, if you're really interested in this,
sure.
in this MediaComp stuff that Mark has shown, we
I
totally
already shared the
own this.
link to the I already shared a link to a course
Great.
course before, but on OpenSAP we do have several Snap courses. One of them being the Media Computation Through Data Science. So this is a 4-week course that covers several topics, and it starts pretty basic, I'd say. So even without any prior Snap knowledge, you can totally participate. But we also try to take a glimpse at the more advanced things. And we also want to show people how they can start working with data. So this is not real data science. It's just basic data science functionalities. And
sure, it's real data science.
Yeah, I mean, come on, actual data scientists are doing crazier things than we do in the course. So we do that by working with media. So we take pixels, we take samples from sounds, we take the Unicodes of text, and we analyze them, we manipulate them to create fun and beautiful artifacts. And then we apply the whole thing to actual real life data. Not that media data is not actual real life data. Anyway, other data than media. For example, the Titanic data set that Mark showed us before. So if you want to participate in that, it's free. Just register. And then there's also an introductory Snap course that is 11 projects about Snap and about general programming construct. So if you're interested in that, also feel free to check that out. And there's another course which we helped produce. It's called Exploring the World of AI. And a lot of stuff that's part of these 7 modules that we showed you is also covered in that course. So Tilman Michaeli, he's also a professor for computer science education at the University in Munich. And he is part of that course together with Stefan Segerer, who's some other CS guy. He's pretty cool and knows a lot about computer science education. So also highly recommend that one if you want to check it out and learn more about artificial intelligence. And this is specifically aimed at teachers and educators, so you might want to take a look at it. Let me post all 3 links separately. Yeah.
Okay. Folks, I think this was it from our side. Any final questions or feedback?